Hello friends, today we are going to see about solving Sudoku puzzles by using brute force approach and backtracking in design algorithms. So, introduction. Sudoku puzzles are renowned for their accessible yet challenging nature, involving filling a 9 cross 9 grid with numbers 1 through without repetition in rows, columns, or 3 cross 3 subgrids. Beyond entertainment, Sudoku offers cognitive benefits, sharpening memory, concentration, and logical reasoning skills. Its simplicity attracts individuals of all ages, backgrounds, serving as both a mental workout and a relaxing pastime. The structured process of deduction promotes mindfulness and stress relief, providing a respite from daily pressures. So, algorithm design techniques used. Brute force approach. Brute force involves exhaustive checking of all possible solutions until the correct one is found. In Sudoku, this means starting with an empty grid and trying every possible combination of numbers that adheres to the puzzle's constraints, while it guarantees a solution even for the most challenging puzzles. Brute force can be computationally expensive, especially for larger grids, as it involves exploring a vast number of potential solutions. However, for smaller puzzles, it remains a viable option, ensuring a solution is eventually reached. So, solving Sudoku with brute force algorithm. Begin, begin with a empty grid. Generate all possible number combinations. Validate each combination against Sudoku rules. Continue until a valid solution is found or all combinations are exhausted, which can be computationally demanding for larger grids. Time complexity for brute force algorithm. Best case order of 1, average case order of 9 power 9 square n square. So worst case order of 9 square 9 power of n square. So backtracking algorithm. This algorithm technique involves systematically trying out different options and undoing those that fail. In the context of Sudoku, backtracking starts with an empty grid and attempts to fill in one cell at a time. At each step, it tries placing a number that fits the puzzle's rules. No repetition in rows, columns, or subgrids. If it reaches a dead end or finds a conflict, it backtracks to the previous step and tries a different number, continuing until a solution is found or all possibilities are exhausted. So solving Sudoku with backtracking. Algorithm start with an empty cell, trying placing a number from 1 to 9. If valid, move to the next empty cell. If not, backtrack to the previous cell and try the next number. Repeat until the grid is filled or no solution is possible, ensuring each number placement adheres to Sudoku rules. So by this way, the Sudoku solver works by using brute force and backtracking. So see here, by brute force we approaching all values in the box. So finally we attain the correct number for every and each box in the Sudoku. So time complexity for backtracking algorithm. So best case, while rare straightforward puzzles may be solved quickly with minimal exploration, this scenario typically exhibits a constant time complexity of order of 1. Average case, so order of n power m to order n into m whole power n, where n represents the number of empty cells and m denotes the branching factor. So worst case, order of n power m whole power n. In such instances, the algorithm explores numerous possibilities before reaching a solution, making it computationally intensive. So comparative study, so brute force algorithm. So and we are showing the difference between brute force algorithm and backtracking. So brute force best case order of 1, average case order of 9 power n power 2, and worst case order of n 9 power n power 2. So backtracking best case order of 1, average case order of n power m to order of n into m whole power n, worst case order of n into m and whole power n. So backtracking and brute force algorithm solves Sudoku. Backtracking with a time complexity ranging from order of 1 to order of n power m. So is more efficient, especially for larger puzzles. Brute force consistently operates order of n power 2. So exhaustive checking combinations rendering is less practical for larger grids compared to backtracking. So result, backtracking systematically explores the puzzle grid intelligently, trying different combinations of numbers. It employs the depth first search strategy, so efficiently traversing the grid and minimizing unnecessary exploration. It optimizes memory usage by only retaining relevant information, reducing the computational overhead compared to the brute force. Overall, backtracking often leads to faster solution by intelligently navigating the puzzle space and eliminating unnecessary exploration. Backtracking time complexity typically ranges from order of 1 in best cases to order of n power m in worst cases, which is generally more manageable than the consistently exponential time complexity of brute force. Therefore, backtracking is a superior approach for solving Sudoku puzzles, offering a balance between efficiency and effectiveness. So, by the way, I completed the Sudoku solving using brute force and backtracking.